Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 3 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1578. Minimum time to make rope colorful. So let's read the problem statement. Alice has n balloons arranged on a rope. You are given a zero indexed string colors where colors of I is the color of the ith balloon. Alice wants the rope to be colorful. She doesn't want two consecutive balloons to be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You are given a zero indexed integer array needed time where needed time of I is the time in seconds that Bob needs to remove the ith balloon from the rope. Right. We have to return the minimum time Bob needs to make the rope colorful. Right. So very easy problem statement. Now if you see this example number 1, right. So see here. This is my color string, right? A, B, A, C. Okay. So let's say A is nothing but blue color, right? And B is nothing but, let's say, red color. And C is nothing but, let's say, green color. Okay. So now here, this is how initial string, right? A, B, A, C, right? Now, Alice is not happy with this because here we have two balloons of same color. Now she is going to ask Bob to make her happy and remove one balloon and make it colorful, right? So here, if you see, notice here, these are the two balloons, right, which are consecutive, right? So out of them we need to remove one, right? Out of these two we need to remove one. Okay, now if you see this needed time array, right, so here 3 is the time taken to remove this balloon and 4 is the time taken to remove this balloon, right? Okay, but here if you see in the problem statement, we have to return the minimum time Bob needs to make the rope colorful, right? So we have to become greedy here, right? So what I'm going to do, I'm going to remove this balloon in which we are going to take minimum time, right? So I'm going to remove it. So if I remove it, now I have these balloons, blue, red, blue, green, right? All are colorful. Now Alice is happy, right? So minimum cost is nothing but 3, right? 3 is the minimum cost that Bob took to remove this particular balloon, right? That's it. This is example 1. Now see this example number 2. All the balloons are colorful, right? So Bob doesn't need to remove any balloon, right? So output is 0. Now if you see example number 3, so here again Alice is not happy, right? So to make her happy, Bob is going to remove some balloons. So these two are consecutive. So out of them, minimum cost right here 1. So I'm going to remove this balloon. Then these two are consecutive. So among them, minimum cost is this one. So I'm going to remove it. So total cost is 2. So output is 2, right? In the end, Alice is happy here, right? That's it. And here if you see the constraints, so colors dot length is equal to needed time dot length, right? Both are having same size. N is from 1 to 10 power 5 and needed time of I from 1 to 10 power 4, and colors contain only lowercase English letters. That's it. All right, so now I'm going to solve this problem using two approaches. So let's see first very basic beginner level approach, right? So initially here, first I will do the calculation of length. So n is nothing but I can say colors dot length. So I will calculate the length, right? Now after that, what I'm going to do, I'm going to iterate over all these one by one, right? So here these are the indexing, right? 0 1 2 3, right? So now I'm going to keep my I here, right? And now next time I'm going to start my j from here, right? So here my I is here, my j is here. So I'm going to compare these two colors. Both are not matching, right? Both are not matching. So at this particular position we are good, right? Clear? We are good, we don't need to do anything, right? Now after that, here what I'm going to do next time, I'm going to place my I at this position, J position, and now I'm going to start my J from here. Again, if you see, when my I is here, J is here, both the colors are not matching, so we don't need to do anything, right? Now next time, what I'm going to do, my I is going to be at this particular position, and now I'm going to start my J from here, right? So here I see that both the colors are matching. So what I'm going to do now, I'm going to move J further, right? So my J is going to reach here. Now both are not matching, so I will stop. So here if you see, I'm going to run one loop from this I to until here, less than J, right? In this I'm going to run one loop because colors are same, right? So when I'm going to run one loop here, so what I will do, I will calculate the total sum. So 3 here, 4 here. What is the total sum? Total sum is 7, right? So total sum is 7. So out of them I will remove the max value. So what is the max among 3 and 4? Max is 4. So I will get 3. 3 is nothing but the balloon that I'm going to remove. Why I'm doing that? Why I'm doing that? Okay, so let's say I have 3 balloons of same color, A. Cost is like this, 2 3 4 5, right? So now out of them, out of these 4, you need to remove 3, right? Because you don't want consecutive, right? So which 3 you are going to remove? You are going to remove these 3, right? In which we are taking minimum cost, in which Bob is taking the minimum cost, right? So I can do one thing now. I can do one thing here. I can simply do one thing here. What is the total sum? 2 plus 3 plus 4 plus 5. Total sum is nothing. 5 plus 4 9, 9 plus 3 12, 12 plus 2 14. Total sum is 14, right? Among these 14, right, total sum is 14. Among these 14, I need to remove this, right? So I need to remove this. So this is nothing but this is the max one, right? This is the max value among them, right? So I need to just keep it only, right? So this is nothing but max. So I am removing these, I am removing these, right? And total sum I know is 14. So total sum I know is 14, and I know the max value is nothing but 5, right? I only need to keep one balloon, so I will just become greedy. I will keep the balloon with the max value, and all the smallest value I can remove, right? So 14 minus 5 I will do. 14 is total sum, 5 is the max, so I will get 9. So 9 is nothing but a sum of these removing ones. 4 3 7 8 9, that's it. So that is why I am doing this. Okay, so this is done. Next time my I is going to start from I is going to start from here, and J is going to be here, right? So that's it. So now J is going out of bound, and then also I is going to go out of bound. That's it, right? So here if you see, I am running a loop like this. First my I is here, then my I move here, then I move here, then I move here. J is only, I'm running J only when there are consecutive elements, but overall I'm just running one loop, right? Like this, in a linear way, right? So time complexity, I can say, is going to be of n only, right? It doesn't matter that we are going to use nested loops, right? Because my I is moving forward continuously, and J, if my I is here, then J I'm moving here, J I'm moving here, J I'm moving here, J I'm moving here, right? So if I cover this window, next time my I is going to start from here only directly, right? If I cover all these elements, right? So here if you see I is here, then my J is here. The next time I is starting from here, not from here, right? So I am only visiting all the elements once, and from all these elements I'm checking if they are consecutive elements. If they are consecutive elements, I'm directly removing it, and then next time I is making jump directly to the last J. That's it, right? So very simple approach, right? So let's write the code with this approach. Nothing complex in this particular approach, right? And after this I'm going to show you one more approach which is more simple than this one, right? Very few lines of code in that, right? So here, and is nothing but colors dot length, and then after that int cost is equal to 0, right? And then after that you have to simply run one loop. Int I is equal to 0, I is less than n, and here I plus plus. And now inside this I told you that J is going to start from I plus 1, right? And once this is done, then after that here I will check the consecutive elements. So what I'm going to do here, I'm going to write find the end of this color group, right? So I will write while J is less than n, and here and colors dot char at this J value, right? If it is equal to colors dot char at I value, right? So that simply means that colors are matching. So in that case, just increment the value of j. That's it, right? So now next time we have to calculate the total and max time for this particular group. So here I'm creating two variables, int sum is equal to 0 and max is equal to 0, or yeah, you can say 0, right? Because here if you see in the constraints, so the needed time of I value, right, is always starting from 1, right? So definitely we will get some bigger values only, right? So that is why you can say max equal to 0, right? Then after that run one more loop, int k is equal to I, and here k is less than j, and here k plus plus, and here sum is total sum I am calculating, right? Sum is nothing but you can say sum plus needed time of k value, and max is nothing but math dot max of max, and here needed time of k value, right? That's it. And here we have to add the cost to remove all except the max time balloon, right? So cost is nothing but the overall answer that we have to return is nothing but cost is equal to cost plus sum minus max, right? Cost we have to add every time, right, for all the groups. So here sum minus max for this particular group, this is the cost. And then next time I told you that my I is going to be at j position, right? But here I am already incrementing I here in the for loop, so here I will just write j minus 1, right? So that's it, move I to the end of this group, and that's it. And here you have to just simply return cost, that's it. Okay, so now let's run the code and see. So here, yeah, so this is string, right? So you have to write it like this, right? So now let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So here this loop we are running of n time, right? Basically time complexity is because of this only, right? And then j I'm running and I'm finding one group, right? And in the end I'm directly jumping my I value to the last j value, right? And here in between I am running one k loop from I to j, right? So overall time complexity is going to be dependent on this of n value, right? So that is why my time complexity is going to be of n for this particular problem. Okay, so that's it. So this is approach 1. In approach 2, what I can do, I will show you one more simple way, right? So here if you see, we are checking like this, right? 3 and then 4. So I can compare these two values directly, right? This and this. So if both are same, right? So among them your cost is going to be minimum value, right? Cost is going to be minimum value among these two, right? Clear? Cost is going to be minimum value among these two, right? And then this is what you need to do, right? Okay, so here in approach 2 I'm just going to run one single nested loop, one single loop, not nested loop. Okay, so this is what you have, right? And here these are the needed time 1 2 3 4 5, right? So what I'm going to do here, I'm going to compare, I'm going to start my I from here, from this bed position, right? So here if I just give the indexing 0 1 2 3 4, right? So if my I is here, so I'm going to compare this with this, right? So both are matching, no, then my I is going to move here. I'm going to compare this and this, so both are not matching, right? So now next time my I is going to move to this position, right? So when my I is here at this particular position, okay, when my I is here, so I'm going to compare these two. So now both are matching. So in this case I will update my cost as cost is equal to cost plus minimum of math dot min of, and here needed time at I index, needed time at I, and here needed time at I minus 1. So I will update my cost like this. And next time here I am going to update needed time at I. Why I'm updating this needed time at I? So here among these 3 and 4, right, uh, I will update here max value, whatever the max value. So math dot max of, same here, needed time of I, needed time of I, and needed time of I minus 1, right? Why I'm doing that? Only these two lines are important. Okay, so here in this case we have just two ways, right? So among them you get the cost, and you need updating needed time here. 4, it is 4 also previously, now again 4. Next time your I is going to move here, you are going to compare these two, both are not matching, that's it. So you are going to return the cost as 3. Okay, this is very simple for this particular example. But let's say why we need this line. Let's see this example: a, b, and then we have 3a, then we have c. So here we have 1 2 3 4 5 6, the 3a and then c. Okay, like this. So now in this case, let me just shuffle these values also. Here let's say we have 4 6 and 4 6 and 3, like this. Okay, and here let's say 4 5. All right, so now we have all values like this. Okay, let's say, right, so now here among these two, these both are same, right? So you have to remove one, right, among them. So which one you are going to keep? You are going to keep the max one among them, right? So you are going to remove this 4, right? This is what you are going to do, right? So cost, in cost you are going to add first plus 4, you are going to remove it. Next time you are going to compare these two, right? So here first 4 and 5, which is max, so needed time you keep it as max 5 only, right? Now here 5 and 3, which is minimum. Minimum is 3, right? So this is what you are going to remove, right? So here you are going to add 3, so cost is 7, and here among them max is 5, so max 5 you are going to keep it here, right? And then after that, let's say here we have one more a, right? And here this a value is nothing but 4, and here we have c 6, right? So now here again this a you are keeping with 5, right? And this a4, now see this 5 I am bringing here, right? So now 5 and 4, which one you are going to keep? You are going to keep this one, right? And you are going to remove this, and here again next time 5 is moving forward, right? So needed time, because needed time here I am passing every time, right? Needed time of I. So this value I always want to be max only, right? Because in cost I am adding the minimum, so max is going to be shuffled, right? Okay, a and a, so here 2 3 a 3 2, right? So among them I'm going to remove this, I'm going to remove this. So next time if we have one more a, so if I'm removing minimum, right, so I'm comparing these two, so I want cost to be here 3 only, right? Max. Here if 3 and 2, I'm removing 2 1, this one, right? So here 3 I'm going to compare with this one, right? So that is why needed time of I am keeping it max here, right? So that I compare this max with this, right? And in this way I will remove always minimum one, right? So single loop. Okay, so very simple. Just go over the code and only few lines of code. So here let's keep this same, and here int I is equal to, right, inside this we are calculating this stuff. So let's do one thing now. Here let me just remove it for simplicity, right? And here instead of 0 start from 1, and here that's it. And here you have to just write if colors dot char at I value, if it is equal to colors dot char at I minus 1 value, right? In this case only you need to update your cost as math dot min. In cost we are always adding the min, right? So here needed time at I, and here needed time at I minus 1, that's it. Okay, and just up copy this, and here paste it. Here we need max value for the, if my I is moving forward, so previous I is nothing but I can say needed time of I, the new value, right? After that my I is moving forward, right? So needed time of I is nothing but math dot max of needed time of I and needed time of I minus 1 return cost, that's it. Let me just format the code and let's run it to see if we are able to pass all the test cases or not. So there is some issue, right? So that is why I ran this program first. Now let's run it again to make sure that all the test cases has been accepted. Right, done. Now let's submit it. So this is the next approach, right? Approach 2. So see, with this also we are able to pass all the test cases, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.